All right. Hello, good morning to everyone. My name is Nathan Cook. I will be your MC moderator today. Getting a chance to talk tech with you guys. So we had the opportunity to get George Crump from StorONE on here to talk about some of the cool new features and technology they have going on right now. So just a little bit about me is my name is, again, Nathan Cook. I'm Enterprise Sales Director here. I've been here since 2006. Started here just as kind of someone who's working on generating new accounts, and now I've had the opportunity to work as the Director of Sales position for about the last 2.5, 3 years. Married with 2 kids, love life with there. We're all big Star Wars fans, as you can kind of tell from our Halloween picture from a year ago or so. And a part-time rock star, you know, I'm in my own mind. I get a chance to play my church band, and music's definitely a big passion of mine. So moving on into a little bit about Vista, because I know we have a lot of people on here that are people we've worked with for a number of years, and some people that this is our first time getting to explain who we are to you. So my goal is to do this in 3 minutes or less, but we've been in business since 1986, so business for over 36 years. Average tenure of our employees here is about 13 years. So we have a lot of tribal knowledge and industry experience. We have over 20 different strategic OEM relationships, StorONE being one of them, to help serve our customers. And I think that allows us to, as you see there, not have a cookie cutter type of methodology with helping our clients, because we're able to really custom tailor a solution that is your solution versus a solution that a lot of times OEMs just want to throw at you. So our goal today is to kind of explain to you one of those solutions, something that's new in the marketplace. With that, I'm going to introduce our speaker today, Mr. George Crump.
Hey, thanks. Appreciate that, Nathan. So yeah, George Crump, I'm the Chief Product Strategist at StorONE. I've been in the industry for about 25 years. I've been with StorONE for about 3. Prior to joining StorONE, I was founder and lead analyst at a storage analyst firm called Storage Switzerland. I did a lot of work there. You might even have attended one of them. I did a lot of disaster recovery workshops, and toward the tail end, I started to do a lot of work around ransomware, because apparently that's a thing now. So I did that. The other thing is I'm also an avid triathlete. I have done, I guess that's my hobby, and some people might think, well, that's the worst hobby ever, but I've done 9 half irons, and then in 2019, right before COVID, actually, I did a full Ironman. And I'm planning on doing another one hopefully next year. So a little bit of training involved, and so getting the right amount of time sometimes can be difficult, to say the least. So let me go ahead and share my screen. Now, what we're going to do is a little different today. I'm not going to bury you with PowerPoint slides. Our goal is to just kind of go through a whiteboard session and kind of chalk talk through some of the issues. So hopefully it's a little bit more interactive. Just like if I was in your conference room, feel free to put your questions right in the chat there, and we will answer them as quickly as we can. So again, I want to thank the Vista IT group for inviting us in today. Appreciate all that you guys do for us. And so obviously the topic today is ransomware resilient storage. How can we defend and really recover quickly from ransomware? And it's an interesting subject to me, because obviously I've been focused on it for a while now. But we see this dilemma in the industry today. What's really interesting to me is about 92% of organizations, this is a recent IDC study, feel they have adequate tools in place to recover from attack. And that could be true, by the way. You know, there's some features within your primary storage environment. There's some capabilities within your backup environment. You might have the tools. The question is, will those tools perform as well as you think they will? And what we've seen so far in the real world, and clearly the survey will show, is that's the case, and they're not meeting expectations. So as an example, 46% of organizations in this same survey, so it was 500 large to enterprise data centers, admitted to being exposed to a successful attack, meaning that they had data encrypted and compromised. What gets worse and a little bit more frightening is down here. 69% of those organizations had to pay the ransom because they were not able to fully recover. So you've been attacked, your files have been encrypted, and you resort to whatever these tools are up here to get the job done, and they let you down. And sometimes that's process, but a lot of times it's capability of the tool. So in 69%, so a very, very high percentage, had to pay the ransom to be able to fully recover. Now, to sort of add insult to injury, it gets worse one more time down here, right? 50% of those organizations that paid the ransom still lost data, meaning they didn't get all their data back after paying the ransom. So it's actually it was 50% of the 46%. So actually only 19% of the organizations that paid the ransom were able to actually get to all of their data, yet they were, of course, 100% all out the money. If you do the math on this survey and take the average ransomware payment according to data on the market today, we're looking at almost $3 million in payments in just this one survey, right? So it gives you an idea of the scope of the problem, right? Is we've got to come up with better ways to fix that. And so that's really what we're going to talk about today is how can we really address some of these issues. And I think to a little bit, we got to look at the tools because if 92% of organizations feel they have good tools, but more than half are successfully attacked, that becomes a real problem. So if you look at backup, right? Backup will be the thing that most people will turn to as their recovery method. In some cases, it's their recovery method of only choice or last resort or first choice, but it almost always gets involved at some point in the process. So I'm just going to draw a quick environment out here real quickly. So first of all, you've got a NAS system. You've got, I'm just going to maybe include an Oracle database, a Microsoft SQL database, probably a Hyper-V environment, VMware, of course, right? And then maybe another NAS, right? Because most environments have more than one NAS. Those, of course, are all connected to a switch of some sort. And then at somewhere in the process, there's a backup server that may or may not be installing agents to do backups. And then, excuse me, and then that backup software will push all that data to a backup storage device, right? Now, the other thing that's going to happen is while that's all churning, the backup environment creates what's called metadata, right? So this is data about the backups. So configuration files, how many versions of this file do I have backed up, where and what backups are it. So when you go to search for george.doc, it tells you it's in these 5 backups or whatever. But that becomes important. And so if you look at the ransomware attack vector, what we've seen evolve over the years is usually ransomware comes in out here somewhere. And enters in probably through an end user device or through a compromised server in one of these areas, and then starts to propagate as quickly as it possibly can, right? And so what happens is, as part of that process, it will sort of stumble its way through your environment. And one of the things it will stumble into is your backup storage and your metadata. Now, probably more concerning, what we've seen lately is the ransomware attacks will actually now start here, because they know that the first thing you're going to do is turn to your backup solution, And so they also know that if they can compromise your backup data, you're in a world of hurt, right? So that's one thing to do. Now, the second thing we've seen them start to do is also attack this metadata. If they can get to your metadata, they don't necessarily, well, let me rephrase it. If they get to your metadata, but they don't get to your backup data, they don't necessarily have the ability to force you to pay the ransom. What you'll have to do is you have to rebuild. Every backup software on the planet can do a metadata recovery of some sort by reading the old backups. What they're trying to do is make it slow and painful and make paying that ransom even more tempting. Now, somewhat obviously, if they get to both your metadata and your backup data, you're probably in a ransomware payment scenario, right? So these are real problems that people have to deal with today. Now, the other thing we'll see to combat this now is almost every backup software vendor is promoting an idea of an immutable storage repository. And so what happens here is, and often this is object storage. And so what happens here is your backups will come in, they'll hit the backup storage, and then they'll move at some point to the immutable object storage. Now, you might ask yourself, well, why not just back up to the immutable object storage? Well, the answer is object storage is too slow to pull this data in very quickly, right? And so if you look at most of the designs, I would say, I'd hazard to say all the designs, there's a multi-tier architecture now developing in backup storage where we put it on backup storage first, and then we move it to the immutable storage. Now, the problem with this is, if you look at this, you have a situation where this process can take days or weeks to be able to recreate the backup storage, to be able to move data to the immutable storage. And so that allows us, that allows the ransomware time to go in and infect your data again, right? If they can get to the data before you hit the immutable, you're as exposed as you were before. Right now, I guess the good news is you only lose days worth of data instead of all your data, but you still have a mess on your hands. And again, you might be tempted to pay the ransom. So that really becomes a key challenge as we start to look at some of our options here. Now, the other thing to factor in is recovery, right? If we're going, at some point, if you are counting on backup, whether it's on immutable or backup, you want to be able to recover and replace data that has been corrupted on one of these platforms. But understand, this is a unique situation. In a traditional disaster, hurricane, fire, flood, earthquake, whatever, this environment is at least a known state. The state might be your data center is totally destroyed, but at least you know the state. In a lot of cases with ransomware, you don't know if there's not still malware files out there, right? You have to do an inspection process, but you're also under pressure to recover quickly. So you may actually recover directly into a state that is still under attack or still has files there, and you might get re-encrypted a second time. And what we've seen happen when that happens is if the ransomware re-encrypts, the clock doesn't like reset. It sets it to where it was. So you have even less time to make a decision as to whether or not you're going to pay the ransom. And so what we're seeing recommended by both backup software vendors and various people in analyst firms like Gartner and IDC is, okay, we need a third tier here. We need an isolated recovery environment. Right now, so what happens here is this is in a ransomware attack, instead of recovering back to here, this is the system you recover to, right? Now, the problem with that is now we're really adding some complexity to the backup environment. Right now, it's a 3-tier architecture. It's very complicated. It also becomes very expensive, right? This isolated recovery system. It has to be able to deliver some level of production performance, and in some cases, exactly production performance. So that really becomes a big challenge, I think, for a lot of different organizations, right? So if you kind of summarize this section here, what we're looking at is backup storage is a problem because it becomes a target of the attack. Metadata is a problem because it becomes a target of the attack. This transfer time between backup storage and immutable storage becomes a problem because it's just the time it takes, not necessarily that it's the target of the attack. And then finally, the lack of an isolated recovery environment and the fact that you might have to recover into this mess really creates a problem for everybody. So these are the 4 problems that we see typically counting on backup as a recovery tool. So let's talk about primary storage. Why make backup do all the work? What if we had primary storage do all the work, right? And so and there's clearly some features that people know of or probably have at some degree on their current system. So let's go ahead and draw another system in. I'm just going to, in the interest of time, I'm going to make it a little smaller this time. So let's say we have a VMware environment, right? We have a Microsoft SQL environment and a Oracle environment. And of course, we have NAS. It's called NAS 1, NAS 2. The reason I keep drawing NASs in is the painful part of a ransomware attack is when the ransomware gets to your NAS. They're generally not as well protected. There's a lot of files on them. And this is the data that you end up, in many cases, having to pay for. Now, of course, again, all of that connects to a switch and then hopefully to a SAN of some sort. But of course, in most environments, most customers have multiple SANs that they have to deal with to cover the entire environment. And actually, if you think about it, these 2 NAS systems that I drew here was really incorrect, right? They're not attaching in and sharing SAN storage. They are actually their own storage pod out there as well, right? So that's really what we look at as far as a protection environment. Now, so what are the problems with this? So the first big problem is really this, right? That any of the tools that I'm going to talk about in a second are suspect, right? Because the silos means that every single one of these SANs or NASs is going to have its own protection method, its own way of doing things that you might do to protect against an attack. And so your complexity, at least in my picture here, goes by ×5, right? And we talk to customers every day that have 6, 7, 8, 9 different storage systems. Now, the next problem, let me say it this way. The next thing you're going to look at as a tool, though, is probably snapshots in the production environment, right? And snapshots are great. They're space efficient. They give you sort of a redundant copy of data without having to pay the penalty of having an actual redundant copy of data. The problem that we see with snapshots in primary storage is number one, they're too infrequent. And what I mean by that is a ransomware can hit you any time of the day and corrupt all of your data. And most people don't take enough snapshots to be really relevant here. Even in the backup space, we're suggesting that you do a backup every hour or so, right? Not once a day. And so in the production environment, doing a backup or doing a snapshot once a day or even twice a day just isn't very helpful. Now, the second thing is short retention times. Most backup systems, most production storage systems cannot cover the intervals needed to really retain and get backups done, get recovered from ransomware. What we see a lot of times is when an attack happens, you've got to sometimes that attack can span multiple protection intervals. And so you've got to extract different data from different intervals. Well, if you're not retaining your snapshots long enough, that becomes a real challenge for the customer. Now, the other thing that we see a lot, which is a little bit of a problem, is they're hard to find. When you need to get to a specific version of the snapshots, you can't pull those, so you can just finding the one you want. Number one, identifying the one you want, and then being able to quickly pull that one tends to be hard. Now, the other big thing, and this really is a problem, is they also become quite vulnerable, right? They're vulnerable to a ransomware attack itself. Most, or many, I should say, storage systems will allow their snapshots to be exposed, because that way it's kind of easier to get to. But that also means they can be corrupted. They're not hidden from view, and probably the big one is lack of immutability here is a real challenge, right? That you can't. These are not immutable snapshots in many cases. I said before, multiple systems here. You take these challenges and you multiply them by 3, 4, 5, depending on how many storage systems you have, and so that really causes issues. Now, the other tool you might look at is replication. Now, replication is great, right? Because what we're going to do there is we're going to take this environment and replicate it to another system, hopefully off-site, maybe even another system on-site, another system off-site, and that's great. But the problem is the ransomware that can use that same network you're using to push data over that network, right? And so it can attack those environments just as easily as it can attack any of the other environments, right? So that's a problem. And what we see here is a lot of times the replication technology from most vendors is actually dependent on snapshots, right? That they use the technology within the snapshots to push essentially delta changes to the remote site. That makes it difficult to then trigger a separate snapshot at the remote site. Now, the other problem you have is again this siloification of the environment also creates a problem. So if I want to replicate this NAS, that means I got to have a different system over here. Each of these storage systems are going to need their own target to replicate to, so that they're able to perform this function. So, and the same as with the NASs. I'm sorry, the SANs. So you end up with, at least in my picture, 5 different replication processes you have to manage, right? So it just becomes a real challenge, right? Now that's a big issue as well, and so this problem of doing the replication, taking different snapshots, and then the lack of immutability tends to follow, right? So these all also lack immutability as well, so that in that remote site, even if you're taking snapshots, you don't have immutability. And so this really becomes the big problem. Now, a third feature that I'll hear mentioned a lot, and I just want to clarify for everybody, is encryption. And I just want to make it clear that they won't help. If you're encrypting your data and ransomware gets into your environment, ransomware can quite easily re-encrypt encrypted data. You can, in fact, one of the best practices when I'm working with cyber companies is they actually want 3 layers of encryption now, so that makes it harder and harder to decode, right? So you encrypt at the application layer, you encrypt at the storage software layer, and you encrypt at the drive hardware layer. So encryption is not going to help you from ransomware or defending from ransomware. So just don't even think about it. The other big problem is many primary storage systems either don't offer it, or when they do, the performance is so badly impacted that most people don't enable it, right? So if I go back and look at sort of the three problems, like I said, the first one is the silos. The second one is snapshots. That they're too infrequent. They don't have the retention time. They're hard to find. They're vulnerable. They lack immutability. And then all of that, of course, follows into replication. And then the replication is really dependent on the snapshots. And it makes this multiple silo problem, of course, even worse, because now you have to have silos in your DR site as well. So that's all depressing. I think my work is going really good here. So the next step is, how do we make primary storage ransomware resilient? Let's start there. What if we could get ransomware to not even be able to get to the primary storage itself? So I'm going to redraw my primary storage system real quickly here. So VMware, Microsoft SQL, Oracle, and NAS and SAN. So the first thing is to be able to develop an environment where you can consolidate this. The goal is to get you down to one, right? And so instead of this, what we really want is something that looks like this. A dual controller architecture with a mix of different media types, maybe some for performance and some for capacity needs. And then let's take that NAS environment and put it right here. So NAS can be hosted right from here. And of course, the system can also do block. And this essentially is the StorONE environment. Okay. And so the first step is to really simplify the environment by consolidating everything down into one solution. Now, the question might be, okay, well, that's great, but I have different solutions because I need different performance, I need different capacity, I need different cost points. Totally agree with you. So we have a technology called virtual storage containers that allows you to define use case specific quality of service for these different environments. So here I might have a VSC for Oracle, and that might be all flash, right? And deliver 1 million IOPS, right? And then I might have a VSC for Microsoft SQL, and that also might be all flash at 1 million IOPS, right? But then my VMware environment, maybe I just need a kind of a mix. And so it might be HDD and SSD, and delivering roughly 500,000 IOPS for active data. And then my NAS environment, if it's a user share, I might have just a little bit of SSD and then a lot of HDD, right? Because they're connecting remotely, doesn't really matter. And maybe I'm at like 50,000 IOPS. Right. Now, and then finally, I might have a NAS that's more of a production type of use case where I do need performance. So maybe that one's a lot of SSD and a little HDD, right? And that one might do 200,000 IOPS. So you define all this in the product, makes it real easy to set up and synchronize and all that kind of stuff. Now, the beautiful thing is all of this is then replicated at once to another environment in your DR site, and you could have one local and one remote, so you could sort of do a synchronous mirror and then a cascading replication. But that remote site could be configured different, so it could have less flash and a lot more hard drives if you're just mostly kind of using it to sort of hit the DR checkbox. Now, let's talk about those two features though, right? Because now I've solved the one problem. I've simplified the environment. I've made it so a single system can replicate to a single another system. Now I need to make sure snapshots are working. So let's talk about snaps. We call this the feature vSnap. So the first thing, number one, right out of the chute, all snapshots are immutable. Okay, so the moment you take a snap, and they're not, you have to do a special setting or run a special type of snapshot. All snapshots are always immutable. Okay, so they can never be changed. They're hidden from view. You can take those snapshots. You can take those snapshots every 30 seconds if you need to, and you can retain 500,000 snapshots per VSC. Okay, so what that means is you have incredibly powerful granularity. You can retain these for years. With no performance impact. So very powerful capability, lots of retention, no performance impact, so no penalty for doing this. And then finding them, which I kind of out of space here, was a very simple calendar interface. You click on the day you want to recover, it shows you a clock, you click on the time you want to recover, and boom, you've got your snapshot. The other thing that's important here is that the software will alert you that you may be under attack. What we do constantly is monitor for unusually high read and write traffic, read and write IO traffic, and we'll alert you and give you a timestamp as to when it started. So if we're right, you can roll back to the snapshot of 30 seconds before the snapshot that activity occurred, and in most cases see almost no data loss. So very, very powerful capability. Now let's talk about replication. So the big thing about our replication is it's independent. But it's integrated. So it's not a separate package you got to go buy or anything like that. It is built into the StorONE platform. And so you can do these replications. But because it's not dependent on snapshots, I can take snaps over here without any problem, right? So I can have a snapshot copy over here. And then what I end up with is essentially double immutability. Right, so I've got immutable snapshots happening here, and I've got a separate time interval set of immutable snapshots happening here. And so what I've done now is I've essentially created a virtual air gap I've got read-only copies of data in so many places that the chances of everything getting hit is, really the chance of even one place of getting hit is really, really almost impossible. And now I've almost guaranteed that with this as well. Now, as I said, another big advantage is the configurations here can be different. So, if for some reason you said, hey, I want all flash here, you could do that. Right, so this could all be flash, and then this could, on your remote site though, we could replicate to a small flash tier, and then a lot of hard disk drives if you wanted to keep your DR costs down. I do want to mention encryption real quickly. As I said, encryption is not the cure for ransomware attacks, but of course it is. It is a cure for other things like data theft and things like that. All of that happens at the VSC level. Okay, so if I have in many cases today, Oracle and Microsoft SQL both do application side encryption, so I may not do encryption there. VMware does encryption, but a lot of times your NAS either doesn't do encryption or doesn't do it. It has a pretty big performance impact. So what happens here is you can turn on encryption at the VSC level. Each of these NAS instances would be VSCs, and you can get the encryption there. So a lot of flexibility here to do that. Now, so last slide here. or second to last slide. So how do we do all this, right? How can this one company create an application, a storage application that allows you to consolidate so many things? Well, I think the first answer is to go look at what the status quo is today in the industry, right? Most systems, right, they're built on Linux. And Linux essentially has two layers to it. There's a media layer that is actually quite simple, and that fundamentally is what provides the device drivers and connects to the drives, SSDs, hard drives, whatever. Then the other layer, though, is sort of volume management, LUN management, things like that, and that's a bit heavier and adds a lot of latency. It hasn't been really changed much in 25 years. So this whole section here is a layer that causes challenges. Then the next thing you start to see is vendors will come to market, and their goal is to get to market quickly and have this really cool feature. So they add their data services, I'll just call it for now, up here. And this is the thing that gets you excited and has the cool brochures and things like that, right? But to get to market quickly, there's some work to do in here. And instead of doing that work themselves, what, in my opinion, every vendor on the market today has done is they leverage existing code. So they'll borrow somebody else's replication. So there's many open source and just commonly available code. They'll leverage somebody else's snapshot technology. They'll leverage somebody else's, if they're offering it at all, they'll leverage somebody else's encryption. Volume management, LUN management, protocols, all that is in here as well. So LUNs, protocols, everything, right? And so what happens, your poor little app is up at the top here, and to get down to its goal, the media, it has to go through all of these different layers, right? And so what's the impact of that? Well, it's pretty simple. A lot of overhead. And what we see on the market today is most solutions get about 10% of the performance of SSDs. So a common IOPS on a drive nowadays, an enterprise SSD is 200,000 IOPS. Most cases, most systems are delivering about 20 to 25,000 IOPS, right? Where they should be doing, quite a bit more than that on a per drive basis. Then the other thing is they're getting about 60% capacity utilization. So that would be more of a hard drive thing. And so what happens as a result of that is you end up with very poor utilization of the environment, and people want more smaller things instead of fewer bigger things. So instead of using 20 terabyte hard drives, they'll use 12 terabyte hard drives. Well, the cost per terabyte is almost the same on those. Why not save the space? And that this inefficiency here also creates is the reason why you see slow RAID rebuilds and things like that. Now, so what did we do that's fundamentally different? Is we take this stack and collapse it into a single layer, which we call the StorONE engine. Okay. And now what happens is your app isn't your poor little app anymore. It's a supercharged app, because now it gets direct access essentially to the media. We handle all of these data services in parallel as IO comes in, and it's all on a single plane. There's no, if you will, layers or stacks in our environment. And so what you'll see instead is we'll get about 80% of the performance of SSDs/NVMEs, and we'll deliver 90% capacity utilization of both SSDs and hard disk drives. So much more efficient, much lower cost. I can do 1 million IOPS in 12 to 24 flash drives. And now most customers don't need 1 million IOPS. I understand that. But the fact, really what you do in our environment is you buy enough flash just to meet your active capacity, and then you buy hard drives for everything else, unless you insist on all flash, and we can certainly support that as well. All right, so last slide, where to start? Well, if you've got one of these if you're got one of these environments that is the storage system for it or whatever is coming off of maintenance, or you're just concerned about performance or whatever, absolutely, you could start us there and we could grow. What a lot of customers will do is start with this environment, right? Is backup, right? What if we could make this a lot better for you? And so let me show you what that looks like. So if I took that and said, okay, how do I make this better than what I've seen before? Okay, it's a really interesting idea. And so what we might be able to do what we can definitely do in environments is we could take your existing environment, so your NAS, your Oracle, your Microsoft SQL, your Hyper-V, your VMware, and fundamentally change the way this backup environment looks, right? So network again, backup server, right? Now the good news, all that stays the same. You got your backup software, you like it, or you've at least learned to get along with it. Where we're going to change is in this area right here is all of this, these silos that we create within, or layers or tiers that people are suggesting you create within the backup. So instead, what we'll do is we can install the two S1 nodes, a layer of flash, and a layer of, and a big layer, typically in backup, of hard disk drives, right? And now when backups come in, they land on the flash tier. So this does a couple of things for you. Number one, you can do backups hourly. You can leverage technologies like change block tracking, things like that, to be able to really increase the number of backups you're doing. The flash tier will keep pace with that. When you start doing that many backups, you end up looking like the IO load looks like almost like a database more so than a backup. So this becomes very critical to be able to do. The second thing is all data is immutable. So when the backup completes and hits this flash tier, we take an immutable snapshot of it, and it can't be changed. Okay. The third thing that we'll do, because this is backup, and I know there's some vendors out there suggesting that you buy an all flash backup device. I think that's a little crazy at this point, is we do auto tiering. So we can automatically move data from the flash tier to the hard disk drive tier without you having to do anything. And the other thing is to remember is it remains immutable the whole time. There's not that window of time where you're exposed. So it's always immutable all the time, even if it's moving between tiers. Now, the other thing is, remember that recovery environment. This system is also has the potential to grow into a production system. So let's say you do get attacked, you need to recover. What our software will do is automatically carve out a section of the flash tier and do your recoveries there. And then you can mount this as either a block or file volume, and then reroute whichever to that. And so this allows you to be able to recover in a secure, isolated environment. You don't have to worry about what's going, because obviously out here somewhere, I still got a SAN going, right? So you don't have to recover to that SAN. You can take your time, do your investigative work, those sort of things, and allows you to really be very, very efficient and fast in your recovery effort. And the other thing is while you're in this state and we're presenting data, we're still taking those immutable snapshots. And so, because obviously once I mount and expose a volume, if you didn't get a chance to disinfect everything out here, in theory, I could be attacked, right? So if that happened, we still have immutable snapshots going on here, and then we're 30 seconds away from rolling back. So you're at this point now, you're totally protected. You're back up and running in minutes instead of days. The average, by the way, the average time to recover from ransomware attack is typically 30 days. This is minutes to an hour to be able to get fully recovered and ready to go. So this is a really powerful thing that is a great way to start. And then the nice thing is this can grow. So let's say we've solved your backup problem because we've done a good job for you, and then a year or two later, the storage you're using for VMware comes off of maintenance, or it reaches end of life, or whatever has to happen there. Then you can just move your VMware environment to us and use us as storage to support that VMware environment. So it's a backup storage target that solves the ransomware problems for you, and then also gives you a path toward a consolidated future. So that's probably a lot of information. Let me go ahead and stop there. And Nathan, I'm going to bring you back in and let you kind of take us through any questions we might have.
On to our questions for you here, George. The first one I have here is just how is StorONE purchased? Is it an appliance? Is it something you just buy the software application, put in your own data or hardware? What does that look like?
Yeah. So hang on, let me, if I can, I'm going to bring up the screen share real quick because it's probably easier to show than anything. The short answer is yes to all the above. You can purchase it however you want. And so the way we do that is, one second, is we can deliver a turnkey solution that is, basically all of this. And you just plug it in and you start going. You can buy just the software, have your team put together the hardware configuration and bundle it that way. I think that frankly is probably the best way to do it. That way it gives you a lot of flexibility. And then finally, depending on the situation, we can leverage in some cases hardware that's there, especially the controllers. In most cases, you want to buy the storage enclosures with media from somebody like Vista IT to get that part going. So it's really up to you. What are you're most comfortable with? If you want the turnkey solution, if you want a sort of an integrated solution leveraging Vista IT, or if you want to just kind of repurpose some of your gear, we can support that as well.
Perfect. Next question I have is, how do you stop an attacker who has full access to the environment from wiping your drives?
Well, I guess the short answer is don't let that happen. But that's really our responsibility. So two things. Number one, the system has dual factor authentication, so that that'll prevent that. And then secondly, coming actually this quarter, which is less than 45 days away to being done now, is the ability to it'll be an option, and you'll select the option, and it'll basically say, look, if I have the only thing that can delete snapshots is the schedule. So a admin even can't log in and delete a snapshot. And then if the volume can't be deleted if there's active snapshots. So 2 layers. And then, like I said, there'll be 2 ways to manually to actually delete the snapshot in advance of the time frame. There'll be 1 way. You'll have to have a key entered into the system, one from our support team and one from your team within like a minute or 2 minutes of each other. So I think we've got that fully well protected, and you'll see us continue. They call that zero trust, and you'll continue to see us do that.
Gotcha. So it's kind of like those keys you see in the movie with the president and the vice president.
Yeah, exactly. Yeah.
Love it. Next question, follow-up question. Has a pen test been executed against this environment and proven to be fully impenetrable, keeping the data safe? Has a business experience a ransomware attack while using StorONE and easily recovered?
So a formal pen test has not been done. We've had outside consultants try to crack it, and they have not yet. and they were bonused if they could. Yes, we have had customers experience ransomware attacks, and they've gone through the exact process that I described. Where they were hit, very large environments. One was a very large file system environment. The other was a large VMware environment. Honestly, understand the size of the environment doesn't matter, right? Because all I'm doing is presenting a snapshot that already exists. I don't have to move data anywhere. So I can just instantiate that particular snapshot and just reconnect everything, and I'm ready to go.
Awesome. And then you're saying, and this is the same question I always have, but a business recovered from a ransomware attack running 300 VMs and somehow recovered in less than an hour.
Yeah, I mean, there's clearly, there's some prep work there. There's some, you got to practice it. Like you can't install our software, not think about it, not practice this method, and expect it to go in 60 minutes, right? With practice, correct networking, understanding how to reroute things, or maybe, if done correctly, not even have to reroute things. 30 to 60 minutes is very achievable.
It's amazing. Thank you. Next question. What else do you need besides this to protect the network connection to this device from being wiped if they find the password, like a separate firewall switches, etc.? Yeah,
so you kind of asked to kind of address that, right? That's on our side. It's, we can't do much about the network itself. We don't own that. What we can do is provide the dual factor authentication and the ability to have undeletable snapshots, against policy and things like that. The firewall and switches. I mean, by the way, I'm not advocating don't do anything else, right? You should do as much prevention to keep this stuff from coming in as you possibly can. What StorONE is the thing. This is the glass you break when all that other stuff has failed. But you should absolutely be doing everything you can to keep it from penetrating you in the first place. You should be doing things like active monitoring to try to detect an attack. There's a lot of canary type software now that allows you to that sort of is the first thing that attracts these attacks that you can use to monitor the environment. Obviously, I've dealt with customers that have been 100% encrypted, and I've dealt with customers that had one server encrypted. Life's a lot easier if you only had one server encrypted, if you caught it fast enough, right? And so being aware and being alert, and again, practice is just like disaster recovery. There's software out there that will actually simulate an attack for you, and to see how you respond, I strongly recommend that you do things like that.
Perfect. And right now, the last question I got, unless last chance for typing one in here, but when a StorONE hardware appliance goes end of life, are you starting over? What does that look like?
Yeah, what that looks like is, let me do it here. So let's say this is, I just want to make sure I was still sharing. So let's say this is a Gen 3 system. So 2 Gen 3 storage systems, and you decide you want to upgrade to either Gen 4 or, maybe if time has gone on far enough, Gen 5. What you would do is take one node down, put in your Gen 5 system. Even though this one is still running Gen 3, you're fine. Make sure that works, everything's connected. Once that's done, you take the other one down, you put in your Gen 5 server, and you're right back at it. No data loss, no data transfer, nothing. If new types of storage media come out, so I've had flash in here a couple times. So you got two options as far as in the media itself. One might be, actually that all flash thing, it's not really working out so great for me. I want to go ahead and add a hard drive tier later. We can absolutely do that. That's no problem. And then what would happen is data would just start spilling down to the hard drive tier. Now, let's say the opposite is true. You need even more performance than what flash is giving you. And so what you do is instead of having a flash tier, what you do is you add a storage class memory tier. And so unfortunately, Intel dropped theirs, but Kioxia and others have storage class memory that have very, very high write performance, which is typically what you're looking for. you can add that later at any time. So the product is very flexible in adding different types of media, both future and old. And again, you keep all this, so you don't take your existing flash and throw it out. You just add storage class memory and start using it. So like here, if we bought it today, we'd probably have a hard drive enclosure full of 20 terabyte hard drives. If you did that in 3 years, you might have a hard drive enclosure full of 50 terabyte hard drives, right? And so when that happens, you're not forced to get rid of this system. We just extend the system. We use the full capacity of both hard drives. We know how to mix and match hard drives within volumes. And the important thing for the user is you don't change any of these volumes. They automatically see the new capacity. And unless you have a policy to, like, say, the Oracle server to not to use spinning drives, they automatically will start using the new capacity as you start to add it. So very, very simple. We expect this system to last for decades, not years.
That's great. And then from a licensing standpoint, if you're using your own hardware and you upgrade that, are there any costs to upgrade the platform, or is it licensing just move over?
So that's the best news of all. The way we license a product was we don't license it by capacity. We actually license it by drive. And so we don't punish people. So let's say you started with a 20 terabyte system. So 20 terabyte hard drives is a petabyte. And then a year or two later, or 3 years later, whenever the time is, you decide you want to replace that with 50 terabyte hard drives, which is almost 2 petabytes, right? You could decommission that and take these drive licenses and apply them to these drives. And so you could upgrade, we call it scale for free. You upgrade, obviously you have to pay for the hardware, but the drive license is transportable to the next generation.
Gotcha. Well, that makes it super easy.
Yeah.
All right, I did get another question here. It's a little bit morbid, but what happens if our main IT guy gets hit by a truck and MFA is not possible? Is there a back way in to support and access our data?
That's very morbid, actually.
I know.
Well, so my assumption would be you probably have more than one person, but if for whatever reason, all the people that are there for multi-factor authentication aren't available, you can call support, and support will have to verify, and then we can get you into the system. Yeah, so we can do that. I mean, it's one of the downsides of the world we live in, though, right?
Yeah.
To some extent, we're making things harder on purpose. And when you do that, yes, you're protected, but it is harder. And so if something like that did happen, it's going to take a little longer than it normally would. But the alternative is you have a wide open system.
Gotcha. No, that's perfect. All right, well, we're wrapped up. Again, we appreciate your time coming in here, George.
Sure.
To have more conversations with you, and thank you for attending. We'll look forward to inviting you out to our next segment of Vista Talks Tech.